All right, so I'm going to welcome our next guest speaker, Dana Wetzel from Moat Marine Lab.
Good morning, and I want to thank Emily and Chris for inviting me to talk today about something that is a little bit different than what you've heard previously, which were talks about specific research projects using community-based interaction or community-based research. What I'm going to talk about today is something that supports community-based research, and that is using traditional ecological knowledge of subsistence communities, and those particularly with respect to the Deepwater Horizon spill on the Gulf of Mexico, but they are communities that exist all over the world, not just in the Gulf. So 6 years ago, it's hard to realize that it's been 6 years since we had that almost 200 million gallon spill over a 3-month period of time. Just to put that into perspective, and I know everybody's heard this forever, but that's one Exxon Valdez spill every 5.5 days, a significant amount of oil. 68,000 square miles of the Gulf was impacted. And not only in the deep water offshore where the blowout occurred, but also near shore, where there's a lot of highly productive nearshore wetland environments that are very important. In those nearshore environments, those wetlands, that's over 50% of the US's continental wetlands are adjacent to the Gulf. That's 5 million acres of very productive habitat. It provides habitat for 95% of all commercially and recreationally important finfish and shellfish at some point in time in their life. So specifically, who was impacted from this spill? Well, fisheries were closed in large parts of the Gulf. Actually, they were closed from May until October of 2010, 6 months worth of closures. So the subsistence people living along the Gulf Coast were significantly impacted. You heard from the previous speakers how much they rely on food they collect themselves to feed their families. There are more than 82,000 commercial fishers in the Gulf of Mexico. 12,000 of those fishers are in Louisiana. There's almost 115,000 recreational fishing jobs in the Gulf of Mexico, and 17,000 of those jobs are in Louisiana. After the spill, there were a lot of multifaceted investigations that were begun. Those investigations were very complex. They looked at physical distribution and dispersion and dilution of oil, chemical evolution and biological degradation of the oil. We looked at environmental effects of oil on the ecosystem. We worked to develop improved mitigation strategies, detection methods, characterization and remediation of oil, and people took all of the above research and put it into the context of public health. Hundreds of millions of dollars have been spent on this critical science that needed to be addressed, and they involved experts globally to try and answer these questions. The problem is that there wasn't a whole lot of resources that have been provided for participation of local communities in the research. It's these people that have the most at stake. They have the best long-term association with the environment, and they understand societal impacts of these sorts of tragedies on their environment. This local knowledge is referred to as traditional environmental knowledge. TEK, or native science, refers to evolving knowledge of indigenous or local people over time, sometimes over thousands of years. Understanding the relationships between plants, animals, and natural phenomena for fishing, hunting, and agriculture and general environmental awareness is very important. TEK is a body of knowledge that's passed down through generations, through cultural transmissions. It's information passed on that's important for basic survival. And it's gathered through observation, experience, and it's recorded mainly orally and told through stories. So what are the differences between traditional environmental knowledge and what we call Western science? Well, in TEK, the information is qualitative generally. The data is generated by resource users. The observations are long-term and they're localized in one area. They integrate and apply this information in their daily living and subsistence practices. And it's based on cumulative and collective experience of the communities. Western science, we're quantitative. Our data is generated by topic specialists. We have short-term observations over large areas. Our work is hypothesis-driven and model-generating. Our work's based on laws and on theories. But it hasn't always been that way. TEK in science isn't new. Historically, it's been used by some really bright scientists. George Rumphius produced a comprehensive botanical catalog. Carl Linnaeus was significant in the development of biological classification systems, and that's what underlies our modern biological sciences today. Charles Darwin, father of evolution. C. Miriam Hart, one of the great naturalists of all times, who developed the life zone concept for biomes in North America. Their research was successful because they used traditional environmental knowledge. But the integration of traditional science and Western science, or traditional environmental knowledge and Western science, is a challenge. It's not easy. There's no roadmap. You have to feel your way through it. But an increasing number of scientists and the native peoples believe that these two approaches are complementary and they can be successful. And this idea is particularly gaining traction in Alaska and in the Arctic. So I want to highlight a few cases that are successfully using traditional environmental knowledge in Alaska. First, during the Exxon Valdez oil spill, both the state and federal agencies recognized the value of the environmental knowledge that the local communities had with regards to populations, the ranges, the diets, and the behaviors of species both before the spill and after the spill. Most recently, the U.S. Fish and Wildlife has used Western science and TEK to make informed decisions on listing polar bears under the Endangered Species Act. Federal and state agencies and the International Whaling Commission rely heavily on TEK for monitoring of populations of bowhead whales and beluga whales and seals and fisheries. The use of TEK in these sparsely populated areas has been integral for supporting science and research. The Arctic is a big, unpopulated area. There aren't that many scientists available. So relying on TEK is really the only way a lot of science can get done. My own work on bowheads and belugas and polar bears relies heavily on community involvement. I have been working up in the Arctic for 15 years, and I'm able to go back time and time again because I involve myself in the community. So what are the ways that you go about gathering and integrating traditional environmental knowledge into your research? This list was put together by a friend and colleague, Craig George, who is a scientist and works in the North Slope of Alaska. And what he says is that wildlife biology is largely observational science, and subsistence people are the best at observing. More observations equals a bigger sample size equals more accurate information. Ask local communities what questions are important to them. In order to be successful, you have to get buy-in from the communities. Get involved in the community and its dynamics. Good communication and trust occur if there's interaction between the community and research scientists. Listen, take notes, and be patient. Oral history takes time to hear. And those people that have the most information of their environment really want to talk about it. Identify your local experts. Local experts will have their own specialties, similar to Western scientists. When I go up and I'm talking to, trying to find information about ice quality, there are experts in the Eskimo communities that know everything about ice. There are 1,000 different words for different kinds of ice. They're the people I would go to find out answers to my questions. TEK observations are useful in designing studies and forming hypotheses. The rich local knowledge that they have can really help direct and guide how you decide what your research project should be and how you can develop your hypotheses. We've heard this before. Always review information with the community before releasing or publishing it. I can't tell you how important that is. You need to be cognizant of the need to inform the community of your findings through community forums, through plain language, through handouts, through presentations. This is their home and they have a right to know what's going on. Visit classrooms, involve students and/or the community in the research. Find ways to involve them. If they feel enfranchised, they will be the best research assistants you ever had. A partnership between scientists and communities directly impacted by environmental changes takes considerable time to achieve trust, communication, and a willingness to explore alternative ways of understanding nature and the natural environment. But the effort is worthwhile scientifically, societally, culturally, and environmentally. Thank you. Questions?
I have a question.
Oh.
Within our coastal communities, particularly in the South, as well as some of your experience within the native peoples in the Arctic, is there any kind of observations that you could give us with respect to working with, say, like the Kashada tribe and other tribal groups, because they do have, some differences in terms of just the way they transfer information and communicate. So with respect to some of the tribal groups within the southern United States, do you have any experience with just their communication modes with scientists like yourself or other people?
Each community is going to be different. Each community has its own traditions, its own culture, and the way that they like to receive and give information. You can't have a one-size-fits-all, and I would reiterate what Andy said earlier. You have to go into those communities, and you have to understand what their lifestyle is like. I will tell you a story. When I first started working in Barataria, right after the oil spill, I went in and I arranged to meet with several community leaders. And they agreed to meet with me at a restaurant that one of their family members owned. And it was like a tribunal. They were at a table and I came in and sat down in front of them. And they said, okay, say what you want to say. We'll listen to you, and if we don't like what you're saying, we'll ask you to leave. So they got stung a lot by people coming down and doing science, not returning and not communicating. So first and foremost, you really have to get to know your communities and listen to what it is they have to say.
Thank you very much.